Nowadays, we cannot imagine life without electricity. It has become such an important part of our life, yet most people know so little about it. Electricity is a real-time energy delivery system. It's incredibly fast, it travels nearly the speed of light. This means that all our energy that runs our lights or television is generated, transported and supplied all at the exact same time. All of our energy was a bit of sunshine on solar panel, atom of uranium, or most likely a bit of coal or natural gas in a steam boiler just a millisecond ago. Because of the laws of physics, all our electricity must start as some other kind of energy. This means that we must convert one type of energy to another to get an electricity. Most commonly, we use heat energy to convert it into electrical energy. We put fossil fuels like coal or natural gas into a big furnace to generate steam. Unfortunately, it has a massive disadvantage of producing enormous amounts of carbon dioxide, the greenhouse gas that is causing the current threat of global warming. The electricity production makes about 1/3 of total greenhouse emissions. That is why humanity needs to start creating electricity in more eco-friendly ways, like solar energy or wind energy. Today, we will show you how to convert mechanical energy into electricity.
This technique is used in steam turbines, water turbines, or wind turbines. For the conversion of mechanical energy into electricity, we use generators. The magnet consists of two poles, north and south. Permanent magnets have constant magnetic field which flows from the north pole to the south pole of the magnet. Generators consist of two parts: stationary stator, which holds the copper coils, and rotating rotor, which holds the magnet. To create a complete circuit, we must take a copper wire, wrap it into multiple coils, and place those coils opposite of each other within a stator. Because of the movement of free electrons, a current will start to flow the circuit. This means that it produces a current that is constantly changing. This process is called electromagnetic induction. As you can see in this animation of our generator, when the magnetic field touches the coils, the electrons will start moving in one direction. When bigger part of the magnetic pole is touching the coil, the faster will electrons move to one direction until it reaches the maximum speed at the center of a magnetic field. Then, as the magnetic field decreases, the flow of free electrons will begin to slow until it reaches a point where no magnetic field is touching the coil, so there is no movement of electrons. Then comes the other side of the magnetic field. As this passes through, it is going to pull the electrons into reverse direction. This is why we call this type of electricity AC, an alternating current, because it alternates in directions backwards and forwards. If we put the speed of electrons on the graph, then we would get a sine wave pattern.
So at the start, electrons are not moving. Then they are going to move faster and faster until they reach max speed at the center of magnetic field. Then it will decrease all the way back to neutral, where electrons are not moving. After, it comes to the other pole, where electrons start to speed up and then begin to slow down again.
But most of the things powered by electricity runs on direct current. So we need to convert alternating current to direct current, and we will going to do that by using bridge rectifier, which consists mainly of 4 diodes, and we will use a capacitor as well. Diodes have ability to allow current flows through them in only and only one direction. So we will get by bridge rectifier great DC supply. But there are still gaps in our direct current, so because of that we will use a capacitor at the end for the smoother DC supply. And now it's time to design our generator. All of the parts were designed in Inventor Professional 2020. As you can see, this is a full animation of generator assembly, and that's exactly how it should like in real life.
Is really working, I will try to generate power which turn on the LED.
Okay, the generator isn't that powerful, but I hope that we prove induction of current.
Thanks to electricity, lives of human beings have become much more easier than ever before. Internet would not be possible without electricity, and we can learn so much through the internet for free. It runs streaming websites like Netflix that provides us with countless hours of entertainment. It saved thousands upon thousands of human lives thanks to modern hospital equipment that runs on electricity. Electricity was so nice to us and has done so many great things for the human race, yet we weren't so nice to our planet. Electricity is such a great servant, but we kept making it at the expense of our planet. Nowadays, we see the effect of it in place. The average temperature of the Earth is still rising. This doesn't mean that we must stop producing electricity to save the planet. No, that's nonsense. We just need to convert all of the coal-fired powered station into cleaner versions of energy producer, like solar or wind. We know it is possible. That is why the production of electricity from renewable sources keep rising every single year. The products that runs on electricity were made to improve the human race. Now, let us create a cleaner energy for the better future.